Every morning, my server wakes up. It reads 500 news articles, finds a market gap, and writes a business plan. It publishes this briefing to my newsletter at GammaVibe.com without me touching a button. I built this because I was curious if an autonomous agent could generate relevant, compelling, and viable startup ideas. It turns out the answer is very much yes. Welcome to my channel. In this video, I'm breaking down the Python architecture, the database state-based pipeline, and some of the bugs I hit, for example with Gemini Flash, and how I solved them. Before we jump into the breakdown, let's quickly look at what the agent actually produces. Here we see the GammaVibe.com newsletter archive, so you can see all the ideas that it's produced so far. Let's actually open up one of them. So there's a hopefully catchy title at the top. There's an image that's generated to try to visualize the problem and the idea. Then we have the signal, the problem, the solution. Here we see the latest feature I just added, audio overviews. So basically auto-generated podcasts. Let's maybe listen to just a few seconds.
So how does that work in practice?
For a flat fee, around $299, the homeowner uses TrueClaim's platform to coordinate lab testing.
All right. I probably won't cover this in a lot of detail in this video, but I will make a separate one and a separate blog post to go along with it that explains more about the audio overview in particular, because that was a real fun feature to implement. Then we have the business case, where we go into the revenue model, the go-to-market strategy. We talk about our moat, why is now the right time to build this particular solution. And finally, the builder's corner, my favorite part as an engineer, where we go over a potential way to build an MVP for this product. This, of course, isn't the only way to do this. Depending on the programming languages and technologies you like, there are certainly many other options as well, but I find that it's a really good and pragmatic way to get started. All right, here we see an architecture diagram of the pipeline that I've built. So let me talk through this a little bit. You'll see there are a couple of columns here. So the pipeline steps are roughly divided into the ingestion phase, followed by ideation, production, and then finally QA and publishing. And all of this is backed by a Postgres database along with the PG vector extension. This is what I use for similarity search to make sure that the ideas I generate aren't too similar to previously published ones. So here in the ingestion phase, we first fetch the news articles from EventRegistry. This is a news API that I use, and I've been really happy with it so far. I will actually show this a little bit more later. So that's the fetch step. We do a brief triage to make sure that we basically reduce the noise, keep only what's actually relevant for our particular use case. So I find that this cuts out about half of the articles. The remaining half are fed into this extract step in the pipeline. This is where we extract actual business signals. So things that point to gaps, friction points that exist in the market, problems that are worth solving, but it also looks at market trends. All of this then gets fed into the synthesis step here. This is where we actually distill these signals into 3 potential ideas. One thing worth noting here, and this is where we get into the database state-based pipeline, which isn't purely linear. So we actually feed in signals that we extracted in the past 4 days. So we look at a rolling 4-day window of signals, feed this into the synthesis step. This allows the LLM to do a lot more clustering and actually look for proper trends rather than just 1 day of data. So this generates 3 ideas each time. We save those in the database, and then we apply a similar strategy here when we actually select the winning idea. I'll talk about the candidate selection a little bit more after I've gotten through the high-level overview of the pipeline, because there's an interesting algorithm at play here. We select a winning candidate and then move into this production phase. We first do a deep dive. So here we ask the LLM to develop this particular idea a lot more, look at competitors in the space, figure out what the moat might be, how might we build this, right, in terms of the tech stack, how might we go to market with this idea, and so on. And once the deep dive generates the overall business model, we feed that into a visualizer step. Here we first generate a prompt for a visualization, And then in the next step, we actually generate that image based on that prompt. Then all of this gets fed into the writer step. So this is really the main step where we produce the fully fleshed out news article that will later get published. This follows a specific template that we prescribe in terms of the structure that we just looked at. And then here are two more steps that I just mentioned for the audio overview, aka podcast episode. So similar to image generation, we first generate a script for this audio overview. I will talk in a lot more detail about this in the future. And then we feed that script into the actual text-to-speech model to generate the audio. Finally, we have a QA step here. So this is another LLM step in the pipeline where we give it the generated newsletter, and it looks for certain signals that maybe there's hallucinations, that it doesn't look viable, and things like that. And this will either deem the article high quality so that it can be automatically published to Ghost, or it'll save it as a draft that I can look at and then manually publish it. Or if the quality is bad, it will simply reject it. This actually hasn't happened yet, but I like to have this step in there just to make sure. Finally, we publish everything to Ghost. Ghost is an open source CMS platform that's really optimized for sending email newsletters, posting blog posts. It handles audio well and all of that, so it's a great platform. So now let's talk a little bit more about this candidate selection phase and how we go about selecting the winning idea. To do that, let's look at my admin interface that I also built for this app. This has been super helpful for debugging and just making sure all the pipeline works as expected. Here we see the list of candidates. So these are all different business ideas. Business ideas have one of three different archetypes. There's the rabbit hole, the friction point, and the meta trend. And again, each run produces three candidates, one for each archetype. Here we see what the theme is for this particular candidate. Each candidate gets a raw score. So you'll see that some are scored very highly, like we have some 95s here. But some are a little bit lower, like maybe a 75. And then is published shows us whether this particular candidate has been selected and turned into a full newsletter post. So some of them have, some of them haven't. And you'll see right here that today we selected a friction point. Then previously we selected a rabbit hole. Here we selected another friction point, and so on. So how do we go about selecting which of these ideas to use? To do that, we can look at the page for the current run. So here's everything for this particular run of the pipeline. This is probably the most helpful page for me. I can see everything in one place. I can see the candidates that we created, the candidate that was selected. I can see the deep dive on the business model. I can see the prompt for the image generator. I can see the full newsletter post if I want to. Here's the QA output and the result of the Ghost publishing step. So if I scroll up here and expand this analytics and meta section here, I have some raw JSON logging that I do to be able to select things like the ranking function that I use for candidate selection. So here we see the candidate list. It's basically a pool of candidates that goes back 4 days, and we have them sorted based on the final rank that we assigned based on a couple of different factors. So the one that we selected for today was this friction point idea here. We see the raw score of 85, which is pretty good. Not mind-blowing, but pretty good. We have a fatigue score of 0.8. That means that we did publish another friction point 2 days ago, but not yesterday. Otherwise, the fatigue multiplier would have been lower and further penalized it because we try to vary the archetypes as much as possible. And then we also assign a similarity score. This is based on this maximum similarity. So we basically look at all ideas that were published in the last 60 days and figure out which of those is most similar to this new idea. So that yielded this value, and then from that we calculate an actual similarity multiplier here. So ultimately, the final score ended up being 43. So then we look at the one before. This was another friction point, so it has the same fatigue, of course, but it actually scored a little bit lower overall because it got a slightly worse similarity multiplier, even though the raw idea was better. And then before that, we have a rabbit hole idea that got a even lower final score. Here it was not so much the similarity, but it was the fatigue, because yesterday's idea was actually another rabbit hole, and so on. So this has been pretty helpful for debugging. And overall, I think this algorithm has been working pretty well. I'm still tuning it a little bit. I'll probably talk about some improvements in a future post. And again, as a reminder for this similarity calculation, I use the pgvector extension for Postgres, and I create an embedding based on the overall idea for the solution, and I store that in the candidate table, and then I use that to do this comparison. And that's been working really well. So let's look just a little bit at the code and the tech stack. In terms of the stack, I'm using Python 3.13 right now. I use Pydantic AI, and I chose Pydantic AI because I need strict schema validation. So if the model forgets a field, Pydantic will catch this and retry. You can see this here. So for example, we have a class for the business signal and for the market fact. Each of these has a couple of fields. So the business signal, for example, has a headline. And in the description, we essentially describe what the LLM should return for this field. So here we describe it as a short, punchy headline for this specific signal. We also have it return a longer description and categorize the signal type as a problem, consumer shift, new tech, and so on. Similar for the market fact, that's basically a stat. So a number like 30% of franchises are owned by women or something like that. And then a context for this statistic. And this same approach is used for the other models. Also worth noting that Pydantic works really well together with a SQL model and SQL Alchemy. I use this so-called base table pattern. So if I scroll down a little bit, so here's the candidate base. So this is the model that mainly deals with the actual fields that the LLM cares about. And then further below, we have the candidate. This is a shorter class, and that extends candidate base. This adds all the database-specific logic. So this includes things like the UUID-based ID field, the created add field. It has a foreign key that points to the run. Here we have the vector embedding for pgvector that I mentioned, and so on. So just the database-specific logic. Let me now talk about some of the interesting bugs that I've encountered. Here we see the individual steps of the pipeline. And now we're looking at the extraction step. Again, this is the step where I feed a batch of 10 articles into the LLM and have it extract business signals using the models that we just looked at. And one of the things I wanted to do is ideally use a cheaper model here, like Gemini 2.5 Flash instead of Gemini 2.5 Pro, which I use for most of the more sophisticated steps in the pipeline, like the actual writer step. Flash is a lot cheaper, and that does make a difference for a step like this, where I process a whole bunch of batches every day. And this actually worked pretty well overall, but Gemini 2.5 Flash gets a little bit lazy sometimes. And I was initially passing in article IDs based on the UUIDs that I had in my database. But Gemini Flash got lazy, and it actually truncated some of those UUIDs, which then, of course, led to problems mapping them back and figuring out which articles it talked about. So what I ended up doing was add a mapping step that just assigns sequential numbers to articles before passing them into the LLM. This function here, prepared indexed inputs, this is actually defined in the superclass because I'm using this in another step as well. So here we basically just assign sequential numbers. And then later, when we get the results, we call this function to turn those numbers back into the actual IDs. And that allows us to cleanly extract and process the results. This is just one example. And with this fix, I'm able to use a cheap and fast model, which really does make a difference here. Another example, in the writer step, I also briefly tried using Gemini 2.5 Flash, at least in development, to write the newsletter. And while this mostly worked, it would sometimes stop mid-sentence or hallucinate. So I basically just had to give up on that and force the writer step to always use the Gemini 2.5 Pro model because it has the reasoning capability that's needed for this kind of long context generation. And since this step only happens once for the whole pipeline run, it really doesn't make a significant difference in terms of cost. I wanted to briefly show Pydantic Logfire as well. This is actually another reason why I really like my choice of Pydantic for this project. So I get not only the Pydantic models and Pydantic AI with the validation and everything, but it also comes with Logfire. This is a web-based logging tool. I can see all of the requests that I made to the Gemini model. I can inspect them, I can search them, I can go back, multiple days and all of that. And I'm actually not paying anything for this. I'm still on the very generous free tier. Pydantic also isn't paying me anything to talk about this. I'm just a fan of the tool. So here we see all the calls that I made in the last 12 hours. So for example, we have the triage, extraction run, right, feeding into the deep dive, synthesis first, deep dive, visualizer, writer, QA, podcast, and so on. Let's take a look at the extraction run here. So if I scroll all the way up, here we see the system prompt. That's just passed in verbatim from what we saw in the code. And then down here, we have the user prompt. So extract insights from this batch of news articles. Then we have a JSON structure of all the 10 articles that are in this batch. And like we talked about, here you can clearly see the integer keys that we're passing in after doing the mapping. So the first one starts with key 0. And then it's a little hard to find in this big JSON output, but somewhere down here, the next one should start with key 1. Down here, actually, I spot key 2, and so on. And then below, we see the actual output that Gemini returned. This is all returned based on the schema that we specified using our Pydantic models. So here we have a list of insights. Each insight consists of this object that has an article ID, and then a list of business signals and a list of market facts. They don't all exist for each article. So this one, for example, only had 2 business signals. The first one here, the immense power requirements of AI computing are forcing tech giants like Meta to seek and secure their own power sources rather than relying solely on existing grids. This indicates a growing infrastructure challenge for AI adoption. So there we go. That's an interesting problem that we identified. And then scrolling down a little bit more, here's another example. This article had both a business signal, something about the Kia EV2, but then also some market facts. So here we see something about the expected cost of the EV2 and US consumer disdain for small cars and things like that. Anyway, this is a super helpful tool, both to make sure that things are actually working as you expect them to. I've definitely noticed some things just by browsing these logs, but also for troubleshooting specific problems. I wanted to show one more thing. This is EventRegistry, the news API that I use. Getting a good news feed is really critical for this particular pipeline. I can't just scrape random RSS feeds or anything like that. That would just be noise. One feature I particularly like about EventRegistry, which is also known as newsapi.ai apparently, is so-called topic pages. So these are pages that I can define that consist of complex parameters and queries that can weigh different sources and things like that. So here, for example, I can specify for this particular topic page that I want to see content that's at most 1 day old, only English content. I have some categories that I'm interested in. So for example, I have not included things like politics and so on. I'm focusing on business, tech, science, and other categories like that. And then I have a list of specific news sources that are of interest to me. I can even dial in weights. To be honest, I don't know how much this really matters, since I'm really getting most of the articles anyway, and then doing another pass of triage and extraction. But there is a lot of fine-tuning that I can do here about the sources that I include and don't include in this topic page. So this is super helpful. They have a very clean REST API, but they also have a nice Python SDK, which I use that makes it even easier to integrate with this. Very, very solid. I haven't had a single problem with this. I also wanted to briefly show Ghost CMS again. This is the solution that I use to actually publish the newsletter. One reason I chose Ghost is because it's open source, and it's actually really, really easy to run it locally on my dev environment or on my Raspberry Pi-based staging server using Docker. Very, very easy to get it up and running and essentially get a full replica of my production setup for testing purposes. I do use the paid tier for the GammaVibe.com website. I needed the paid tier because that supports the admin API that I use. Ghost also has really excellent email deliverability through its integration with Mailgun, which of course is arguably the most important thing for a newsletter product. And of course, Ghost supports monetization. Let me show briefly how that works. So I can click on one of these posts. This was the one from today. This is the admin version of it. This is also what it would look like in an email, by the way. And then scrolling through here, you'll notice this divider. So this is where the free public preview ends. So if you're not a member, this is all you can see. And then you get this paywall, which asks you to upgrade to a paid tier, and then you can get access to all the rest here. So Ghost handles this very, very elegantly. It's very easy, very solid. So really happy with this choice. I wanted to briefly talk about the cost breakdown as well, since people are always curious about the cost for these sorts of AI projects. So here's my breakdown. The biggest cost will end up being EventRegistry, my news service. I'm still on the free tier right now. So basically when you subscribe, they give you a fixed quota to try things out. And once you've exhausted this, you need to move to a paid tier. The lowest price that they advertise is $90 a month. Apparently, you can reach out and discuss other options because that tier actually is much more than I need. So I'll see what they say. After that, we have Ghost Pro. So I'm on the $35 tier. That's, again, what I need for paid subscriptions and the admin API. Here we have the actual hosting fee. So I'm using a DigitalOcean Droplet, as well as their managed Postgres service. This is about $22. And then Gemini itself is only about $20 a month. So it's less than $1 a day. It's probably closer to $1 now. So maybe this is more like $30 a month now that I added the podcast feature, but it's still a relatively small portion of the actual cost for this. This was pretty deliberate because I specifically went with a business model that scales well. I only need to generate things once, and then every user can see the same newsletter. They get the same audio overview and everything. If I had to actually generate bespoke newsletter posts or podcasts for each individual user, that would be pretty difficult from a cost perspective to make that viable. But yeah, as it stands, it's around $80 a month now, and it'll be closer to $170 a month once I start moving to the EventRegistry paid tier. Also worth pointing out, this video overview is essentially a video version of this blog post that I wrote. And I really did the video because a lot of people found the blog post helpful. And I know not everybody likes to stare at a wall of text. But if you do want to stare at a wall of text, there's a few more details that I get into here as well. So I'll put a link in the show notes. Feel free to scroll through this at your leisure. I'll almost certainly post additional breakdowns like this or go into more specific topics like podcasts in the future. So if you want to see more of this, take a look at GammaVibe.com, both for the generated ideas, but also for the engineering underneath the hood. If you enjoyed this video, please like and subscribe. And even better, leave a comment and let me know what you would do differently, or maybe what areas you'd like me to dive into more in future videos, or if there's any other feedback you might have. Thanks for watching and see you next time.